I'm Dr. Mohammad Rafi, Associate Professor, Department of Cybersecurity at Institute of Aeronautical Engineering. Today I want to discuss about Posix signal handling. Posix signal handling is nothing but a portable operating system interface signals handling. A signal is a electromagnetic and electrical current that carries the data from one system to another system or from one device to another device. A signal is a message sent to a process. The receiving process can try to ignoring the signal or call a routine is called as a signal handler. After returning from the signal handler, the receiving of the process will resume the execution at the point at which it was interrupted. The system calls to deal with the signals vary between the one Unix version to another Unix version. Here is the signals can be sending in the form of the electromagnetic waveform from the one network to another other network. That means here the system operating system is the portable. Whatever the signals now we are transferring from one device to the another device now with or without other modifications that can be utilized. That is the meaning of the portability, the operating system. So which is acting as a interface between the devices. Now here is the signal is a information, the message information that can be sending to the process. Process is nothing but a performing the actions. The receiving process can try to ignoring the signals and call a routines, number of routines, which is we are calling it as a signal handler. Which handler? This handles the signals, incoming signals are, so these are the signal handler which is handling the incoming signals. And a signal is a function of one or more variables that indicate some other phenomena, that is a which signal serves as the carrier of the information between the communication device. That means here this signal which is carries the information between the two networks or communication device. That's why it is acting as the carrier of the information which carries the information. They can convey different types of the information depending on the applications required. Whatever the applications are required depends on that application now which is conveying different types of the information. Portable operating system, that is a POSIX stands for the portable operating system interface. Portable, that means here with or without modifications now we can utilize them. Here is the signal names. Different the signal names are SIG HUB, that is terminating the process. That means HUP, SIG HUP terminating the process. That means here which hang up the controlling terminals. Controlling terminals are the process, that is a terminating. And SIG INT, that is a interrupter. Interrupt means here terminate. Whenever the interrupt is arise while the transmitting the signal from one device to the another device, now the interrupt, if any interrupts are arise, that can be the terminated. That is a terminate from the keyboard and a control. So that means here the key indicator is a control underscore C. The Posix is yes. That is a which is active Posix is yes. Yes means here now which is acting as a portable operating system as a interface. And signal quit, SIGQUIT, quit. That is a here the default action is a dump. That means now here which is quit from the keyboard or any system or the controls. SIG SIGILL. So it is a default action also the dump. That is a illegal instructions. If any instructions are illegal in a signal, so immediately that can be SIG ILL. These are the signal name will be arised. That means the Posix will be the S. And SIG trap. SIG trap also it is a default action is a the dump. So trap means here now which is a breakpoint for the debugging. If any the code is signaling, code is debugging. Now this the SIG the trap signal name will be the dumping and breaking the. So that is breaking the debugging the process. That is the next SIG ABRT. This is also default action. It is a dumpo. That is a abnormal the termination. The meaning is a abnormal the termination. Here is the Posix is S and SIG IoT. That means the equivalent to the SIG ABRT. So it is the Posix is now we are not considering the portable operating system interface here. And we see SIG bus. That means the default action is the dumper. But here whenever the bus error is arise in a signaling process from one device to the another the device, whenever the error is arise, now these SIG bus will be the activated. That means here, so in bus error generally in a bus error portable, now we are not using the portable operating system as a interface. And SIG FPE, that is a default action is a dumpo, and SIG F the PE is a floating point exceptions. That is a S. And SIG kill. SIG kill which is a terminator and the forced the processing termination. Here is a portable operating system. Now we are using portable operating system. It is a S. That means here the process, whatever the process, the actions are performing by the function. Now the process can be terminated by force. So at that now we are using the SIG the kill. Signal the killing. Forcefully the termination can be done. And available to the process. Available to the process that means here SIG US R1, that is a terminator that will be the available to the process. Now we are using the portable operating system for that. The number of the signals names now we are signal names are now we are using while the communicating the signals between the devices, the two other devices. Here for the best the example for these the signals are rail trains. Trains now whenever the trains are whenever the signal is giving, then only the trains are moving. So if the signal is the stop, the signal is the stop here, the trains will be the stop. That means if the signal is the kill, that means the SIG the kill now which is the terminating, that the forcefully the process is terminated. The trains if any damages in this the transmission line, in transmission lines if any damages are arise, so now we can terminate the the process. That is signals can be the kill. Signals can be the kill means now we can remove the processing. So that is a signal the kill. Now we can use a signal kill and a signal ALRM, that is a real time clock, and signal term, that is a process the terminations. And here so all these now we are using signal child, that is it is a default action is a ignore. So child process which is stops or terminating or has got the signal if you trace. That means here the Posix is a yes. Signal the count, that means the continue, resume the execution if it is a stop. Signal stop, that means the default action is a stop now which is stop the signal. That is the name of the, now if you are stopping the process of the execution, now we are using the signal name as SIG STOP. These names now we are using in a signal the processing. Posix now we are saying it as a process signals the handling now with these names now can handle the signals. stop process issued from the TTY. That is a SIG TSTP. That is we are stopping SIG TTN. That means background process requires the input, and here the background process requires the output. That is SIG TTOU. The background process, signaling background process now, which is requires the output here. So these are all the names we can use while communicating, signal communication. Mainly here it is used in a signal communication, and SIGX is a CPU, which is the default action. Also dump CPU time limit is exceeded. Once if the CPU time limit is exceeded, now we can default action can be utilized the dump here, but here now we can't use the portable operating system interface. Yes means now Posix X means now we are using the portable operating system. If you use the portable operating system, now these are the signals. Now you can utilize it. You can utilize it with modifications or without the modifications. With a little other modifications, now we can utilize these are the signals while in communicating the devices between two other devices. Here, the next here that like this here number of 31 other signals now we can utilize. Generally, we can utilize and signal XFSJ. That means file size limit is exceeded. If it is signaling file size limit is exceeded, now we can use the SIGXFSZ and virtual timer clock. That is a terminating SIG VTA L or M. That is a terminating virtual timer of the clock. Now here it is all from 25 to the 31. In this the signaling name, now we are not using the portable operating system interface for transmitting the signal from one device to the another device. Here the signals can be of the different other forms. Now we can utilize while in communication. The signals may be, so it may be, for example, now it may be the human voice or so voltage in a electrical circuit is in the signal form that can be transmitted, and room temperature, so which are controlled by the thermostat systems, the position, speed, accelerations of an aircraft. So here also now we can use the signals, accelerometer and measured with the accelerometers in a mobile phones, force measured with the force sensors in a robotic systems, and electromagnetic waves that can be used to transmit the information in wireless the computer or the networks, and digital photographs and digital music recording. Now these are all the examples of the signals that can be while transmitting from all these in the form of that can be used while transmitting from one network to the another network or from one device to the another device. These are all the different types of the signals now we can utilize. Here some of the conditions that can be generate the signals. Here what is the first the condition? When a user press the terminal key will generating the signals. Generally, for example, when the user break a program, if the user want to break the program, simply by using the control plus key, by using this command, now the end user so breaking the program. That means control terminating the program, and hardware the exceptions. So it will be the generated with help of these hardware exceptions. Now with help of this one, now we can generate the other signals. For example, now division by 0. So it is a hardware exceptions. Invalid memory references and inexperienced the programmers. So SIG, ACGV, that means a segmentation violation of the signals because of an invalid address in a pointer. So these are all the hardware the exceptions or generated the signals. Error signals can be generated. Division by 0, that is an infinity. Error signals it generate the error signals, and the processes can send the signals to themselves by using the kill system calls. If the permissions are allowed, now it use the kill system calls and these other processes can sending the signals to themselves by using the kill system calls. And let's see kernel operating system. So portable kernel operating system can generate the signals to inform process when something happens. For example, signal pipe will be generated when a process writes to the pipe. Whenever the processor, after completing the action, after completing the processing here, the processor will be generating when a process of writing to a pipe while has been closed by the reader. Signals can be sent using the kill routines and the signals and sig action functions. These are all the routines are used to controlling how a process should be the respond to a signal. Every signal has a dispositions in a communication. While communicating between two devices, the signals are processing between the two devices. Now, these are the signal dispositions can be considered. That means which is position will be the change. This is the position here. The position can be removed. So which is depends on if any interrupts are occurred. Now at that situation, now the position will be removed from one location to the other location. Will give the signal from another route. Suppose here if any signals are damaged, for example, in a railways, the trains are if the trains are moving, if any signals are damaged in this route, so immediately the disposition now do the disposition changing the other positions from one path to the other path, which is called the actions that will be associated with the other signals. The disposition is set by calling the signal other action functions. Now, which is calling the signal action functions. Generally, here will be considered three choice of these other positions. Whenever a specific signals are occurred, a specific function can be provided. This function is called the signal handler, and the function is called catching the signal. The two signal that is a sig kill and a sig stop, that is two signal names cannot catch the this is an exceptions, cannot catch the exceptions, and the function is called with a single integer argument, that is the signal number. That the function returns nothing but so here by this code, the code is a construct struct signal actions acting. Signal action, that is a signal child, that is interruption will be arranged at the child, and acting, that is a null. Here in this situation, calling the signal actions and specifying other functions to be called when the signal is occurs. So in all that is required to catch the signals. Here few signals like SIG, IO, SIG, POLL and SIG, URG, etc. These are all the additional actions on the part of the process is required to catching the signals. Additional the actions are required. Here next second one is a signal can be ignored by setting its disposition to sig IGM. That means the signal name now, if you want to ignore the signal, now we can use the signal ignore. SIG ignore means now which is ignoring the signal. So why it is ignoring the signal? It's a disposition. The disposition means now which is ignore one particular path. If you want to transmit, if you want transmit the data in particular the path here, simply now disposition now signal ignoring. Now we are doing the signal the ignoring. No, we will ignoring that one. Again, the two signals sig kill and sig stops are the exceptions will be arised whenever disposition is happened in a signal the transmission. Here signal kill and signal the stops will be arised. So anyway, between the network, in between the two networks, no, generally the signal communication can be done between the two devices or between the two other network networks generally will do this signal communication. We can set the default disposition for for the signal by setting its disposition to sig DFL. That means the default dispositions. Now sig DFL means now this is a signal name. If you use the signal one default, by default the signals are the transmitting. Automatically signals are the transmitting and automatically signals will be the stop. That is the default. The meaning of the signal the default. The default is normally that can be that terminates the process on the receipt of a signal with a certain signals also generating a core image of the process. So in its current working direct, the signals here whose the default the dispositions is to be the ignored, or when it is ignoring signal child and signal URG. Whenever these two signal names are arised, so that will be by the default the dispositions will be the ignored. Sent on arrival of out of the band data. The signaling data is out of band. Now it can be ignored. The disposition should be the default disposition is to be the ignored if arrival of the data arrival is out of the band, and with appropriate the setting in the sig action structure, we can control the current the process responses to the receiving a signal child. Here as well as now setting a signal handler. Signal handler now which is handle the any signals, any error signals, any exceptions that can be handled. If any exceptions are arise while transmitting the signal from one network to the another network or from one device to the another device, now we can use the signal handler. So other behaviors can be set here. So if act.sa handler is a signal, the DFL default dispositions, then the default behavior will be restored by default which is storing the signals and the transmitting. Act.sa handler signal action. Acting means here the signal actions are acting. So this handler is a SIGIGN. So then the signal will be the ignored if the possible signal the stop and signal the kill cannot be ignored. Act.sa the flag is a SA no child the stop. That means here so signal child won't be generated when the children is the stop. Child signal is the stop. Act.sa flag is a SA underscore no cloud, no CLD waiting. That means here the child process of the calling process will not be transferred into the process when they are terminating. So this is the flag can be utilized. That is the flag is SA underscore no CLD wait. That means child processes of the calling process will not be transformed into the process when they are terminated. And signal functions. Portable operating system interface generally so which establishes the disposition of the signal is to call the significance of the functions. That means here the signification of the which is calling the function signification. That means signal actions now which is calling the signal the actions now which indicate the signification of the particular signal. However, so this is a complicated task at one argument to the function. So is a structure so that we must allocate it and file it. That means here so however these the arguments to the function is a structure that now we must be the allocated and fill in it. So an easier way to set the disposition signal function for a particular signal is to call the signal as a function. After calling the signal function only, now you can set the disposition of the functions. Now if you want to disposition, so first you have to call the function. Now it will be happen now if any errors or exceptions will be arise. The real time example is the railway signals are the best the real time example for the disposition of the signals. Now if any errors or any exceptions are arise, in the signal. Generally, now this can be the deposition can be, now we are changing the positions of the signals and diverting the trains. This is a best real time example. And here the first the argument is the signal name, and the second argument is the pointer to the function or one of the constraint, that is a sig ign ignore or sig dfe. Normally now we can define our own signal functions. So if you define your our own the signal functions, that just calls the Posix sig actions. That is a portable operating system interface signal the actions. And signal function having in a transmitting from one device to the another device. Whenever we are transmitting the signal from one device to the another device, now in developing, if you develop the code for transmitting, so which is having the totally 31 other lines of code that calls the sig action functions. Now here in this one here, first two to three lines of code. Now when the signal occurs, it has the pointers to a signal handling function as the second the argument, and set handler we are using. So that is utilized in as a line 6. Now the SA signal the action the handler. So this is a member of the sig action structure. He is set to the function argument. And if you see next, set signal mask handler, mask to handler. So portable operating system interface which allows the signal mask to handler, which is setting. So as to specifying a set of signals that will be blocked whenever it is the blocked now, which is allowing the mask to handler whenever the signal handler is called. Any signal that is blocked cannot be delivered to this particular process. We set the SA the mask member to this the empty set now, which means that no additional signals are blocked. While our signal handler is running on a portable operating system interface, which give the guarantees that signal being catch is always blocked while it handles its the execution. And so remaining and optimal flags. Optimal flags are the SA underscore restart. So it is a optimal flags now, which is using in a signal the development code. Here this it is a set. Now a system call is interrupted by this signal will automatically restarted by the kernel operating system. The function the significances is called, then return the old action for the signal as it returns the value of the signal functions. And Posix signal semantics. That means here whatever the Posix portable operating system interfaces now we are using, now that should be the semantic. Now the meaning, the signal should be which gives the meanings. Once a signal handler is installed, it remains the installed. While the signal handler is executing, the signal being delivered is blocked. Further, any additional signals that were specified in the SA mask signal set that can be passed to the signal actions when the handler was installed are also blocked. When the signal action mask is set to empty set, no additional signals are blocked other than the signal size being cached. Here is if the signal is being generated more times while it is blocked, same signals are generating more number of times overlapping. So in this other situation now we can block the signals. It is normally delivered only one time after the signal is unblocked. It is possible to selectively block and unblock a set of the signals now using the sig procedural mask function by using the sig proc mask the functions. So it protects the critical region of the code by providing the certain signals from being cached while the region of the code is executed, and handling the signal the child signals. Now Here is for handling the child signals now. Zombia is a process. Now we are using this as a process that has the terminated, whose the parent is still running, but has not yet wanted for its child processes. So this will resulting in resource occupied by the terminated process. So not returned to the system. If there are lot of zombies in the system, if you are using the lot of zombies in the system resources may run out. The purpose of the zombie state is to maintain the information about the child for the parent to fetching some time the later. Some information from signaling information can be fetch some limited the amount of the time. Here is the informations. The informations are the process ID of the child. So it is the termination state. Why? Because here in the child the process now actually the exceptions will be arise. The termination state now which when it is activating. So whenever the exceptions are arised, so at a child process level now the termination the state will be activated and terminating the other process. So process is nothing but here the performing some action. That means transmitting, carrying the signals from one device to the another device. It is a process, and information on this resource, which is utilization of the other chain. That means CPU time or memory, etc. If a process terminates, and the process has children in the Zombio states, the parents of the process ID of all the Zombio children is said to be the 1. Otherwise, now which is said to be the 0, which is inherit the children and clean up them. So next, interrupted system calls. Generally, some systems interrupted. Some system calls are interrupted due to the errors. If any error is arised while transmitting the signals, now the signal should be interrupted. There are certain system calls in the client server communications that are blocked while waiting for the input, and it can be seen that. So in this is the case of echo client server. The programming echo client server programming means here it's a communication between the client and server. The same information can be sent between the client and the server. So it can be seen now. You can see in a echo client server programming the communications. So in the server programming here, the function accepts is a blocked while waiting for the call from the client. This condition is called the slow system call. This can also occur in case of the functional calls such as reading operation, writing operation, and select operation and open operation. Here is under such conditions in writing, while writing, reading. So under such some other conditions here, when a child signal is the exception is arised at a child signal, so is delivered on a termination of the process. Whenever the exceptions errors are arised at the child signal, now we can terminating the process. Performance, whatever the actions are the performing immediately, that can be terminated. The signal child the function now which is executes means the signal handler for the child. So which is waiting the function now which is fetches the child PID and the termination the status. The signal handler generally then returns, but as the signal was cached by the parent, while the parent was blocked in a slow system calls. That is the accept. After accepting now the slow system call, now it will be the blocked. The kernel operating system now which is causes the accept to return an error of the signal is a interrupt. That means interrupt system calls. Interrupt whenever it is interrupt system calls are arised while transmitting the signal from one device to the another device, that will be the terminated and giving the new other signals. New signal line will be given to the other devices for transmitting the signaling, for transmitting the other messages. Generally, this can be used for transmitting the other messages from one device to the other device. The parent here, the parent does not handle these the errors. That means here, so it is a abort. abort operation now, so will be performed the child the processors. So these are the potential of the problem now, which are all slow system calls. That is reading, writing, open, select. All these operations can be which will be faced whenever they catch any other signals. This is undesirable, and so that is SA underscore restart flag. So that is a set in a signal other function is not set by the signal other function in the system library. So wherever has some other systems using the library version of a signal functioning, the kernel operating system which is restarting the interrupter system calls, and acceptor doesn't return any errors. Here, handling the interrupt system calls. The basic rule that applies here is that when a process is blocked in a slow system calls and the process catches a signal, and so the signal handler returns, the system call can return an error of an INTR. That means error interruption, EINTR. For portability operating system generally when the programs are written, one must be prepared for slow system calls to return the interrupt errors. IEINTR means interrupt errors will be arised. When the programmers are written, one must be prepared for slower systems. Slower system signaling calls now generally interrupt errors will be arised. Even if some of the system supports SA restart flag, not all interrupt system calls may be automatically be started. Berkeley is derived some implementations and never automatically starting the systems. Here, for example, now handling the interrupt acceptor this is a code for handling the interrupt access. Now we can change the call to accept. So in the server or the program, so in the this is the code for this one, changing the interrupter handle the interrupter accept. Here, see child the length here, now size of the child the address, and if connection file the descriptor, if it is accept the listener file descriptor, signal action, and CL that is client the address now. That means the client address will be now we are considering it as the child, and the client length which will be less than or equals to 0. Whenever it is executed here by executing of these the code now we can handle the interrupt acceptancy. The interrupt can be handled here. So in this the code the interrupt system call is restarted. So these are the method works for the function reads, writes, selects, and open, etc. But there is one function that cannot restart by itself, that is a connect. If this function returns interrupt errors, we can't call it again. As doing so will return an immediate errors. In this case now we must call select to wait for the connections to the complete. Here these are all the reference the books textbooks, these are all the textbooks now. So these are the textbooks. So these are textbooks for the signal the handling in a network, the programming, that is a Unix network programming. Richard Stevens, and references. These two are the reference books, William Stallings and so D. the Corner, and web references. These are all the web references. Now, in these Posix signal handling, with the help of this portable operating system, now we can handle the signals with the help of the portable operating system with the modifications or without other modifications. Now we can handle the signals whether it is a failure or running smoothly from one device to the another device, or one network to the another network, or one locality to from another other locality. Signal the transmission are effectively the working or not. Now we can identify it. We can identify by using the Posix signal handling the functionalities. Generally, these can be utilized in the real-time application of these Posix signal handling means. So it can be utilized in any voice based signals, or railway signaling, railway signals. These are all the real time the application, airline signals, airways. So these are all the real time applications of the Posix signal handling.
Like, share and subscribe. Hit the bell icon for more updates.